Welcome to the webinar today. It is about the three wood fuels and dry wood chip boiler systems. I think you'll find it interesting with the three fuels that we commonly find for biomass. The two original ones, the original by long shot was the green wood chip, and then wood pellets came along a number of years ago, and then dry wood chips came on about 7 years ago, so 6 to 7 years ago. We are presenting webinars every Tuesday in July at 3 p.m. And you'll see that the next one is in some ways similar, but it would be more or less a continuation of this one, where we go into review a number of dry wood chip projects and maybe a few other projects as well, things that we've done that are of interest. Froling Energy centric, but again, we're one of the few companies that are doing the dry wood chips, and people are interested to find out really what this is all about. So the next one, July 21st, is about air emissions, having to do specifically with biomass boilers, the planning process, especially if you're going to be putting in a new boiler of size, something in the 2 million or 3 million BTU mark, something that needs to have regulation, make sure that you're following everything properly. That would be John Hinckley is going to be giving that particular one. And he's a very experienced guy, 20 plus years in the field, now works for a company called All4 Environmental Consulting. And then on the 28th, we're going to have a European-centric webinar where we'll be telling stories about different projects over there. Specifically, district heating will be one of the major focuses, but there'll be other projects as well that will be described. So that is Ludmila Schubert of Schmid Manufacturing. They manufacture boilers. Will be on that particular webinar. She'll be the host and doing it from her perspective, the experience they have in Europe. So we are also recording these webinars. So if you wanted to catch it again, or something you might have missed, or perhaps you want to share it with somebody else, then please go to our website, frolingenergy.com, and you'll see the recordings listed there. And actually, if you click on one, there may be some that aren't posted quite yet, and that will take you to our YouTube channel, which has the full listing. Here's my picture. I'm the Vice President of Sales and Marketing at Froling Energy. I've been doing that for 8 years now. And I've been involved in renewable energy for a long time, and grew up in the Midwest. All those different states we toured as kids, and went to a place called Heidelberg College in Ohio, which I studied American Studies there. And I've been in this Monadnock region here, Peterborough area, for over 30 years. It's been fun. So if there's a question about my background, got to know that we'll be talking about this. I've been pretty much immersed in biomass for the last 8 years, and been thrilled to work with Mark Froling and Toby Wells and the different guys on the crew that do a great job with boiler installations. And you'll see that our biggest market really is school buildings and campuses. We've done more of those, and it's just a great centrally heated, big user of fuel for heating. And that's just been a great application for us. It's a good public building that very often has a need for new boilers, and they're willing to talk about making a good example of their installation. Commercial buildings, industrial buildings, our biggest customers in industrial building. That's a picture of Whelan Engineering there. And then multifamily buildings, residential homes. Individual residential homes, we'll do a few of those a year, but our focus is commercial. That's Applegate Apartments over in Bennington, Vermont, which is a great success story that we worked with a number of other contractors to execute a really good project. So you'll just see that what we do is the biomass boiler system installations. Mainly they are retrofits. There's a few new construction projects, but it seems as though going into an old boiler room and making that thing better, both with the biomass boiler system as well as just new components all the way around. And very often controls and things go in as well. We actually service everything, and the cleanings are probably the most frequent kind of servicing that we're doing. And we also manufacture and deliver these things called PDCs that I'll get into. We're a self-performing contractor. We like to go in as basically handle a job. If a boiler room is needed, we'll build it. Sometimes other contractors are involved, and that's no problem. But a lot of times it's a big part of getting a project is being able to say, listen, we're going to be the one responsible party here. Project development is an important aspect of what we do, talking to engineers and architects and building owners, talking about feasibility, working various designs, different scenarios, different systems, seeing what works best. And we'll get involved in all the mechanical systems. Going into a school boiler room is a daunting thing for me to go in and even look at it, try to figure out where all these pipes are going and how it all connects together. And my guys have that down, so that's a good thing. So what we've learned for the last 4 years or so, and we've been doing this for almost 10, but it seems like the last 4 years, there's been this recent development of projects that are just getting bigger and bigger. It just seems like that's where the need is, and that's where perhaps our talent is. But that's a big part of it. It seems also the price of oil is such a determinant on this. And if the price of oil goes low, the only people that can really afford to make a big switch is a big fuel user. So that's where the bigger project comes in. Reliability is a huge priority. Now, they don't want to get something that's just going to be a burden. So you've got to make sure that the systems are as well designed and the boilers are as reliable as they can possibly be. Cost justification, obviously, and then thermal RECs, especially New Hampshire. The thermal RECs have been a big deal as far as reducing the cost of the fuel even further than what a wood chip would do. So that really makes things happen. And PDCs, you'll find out more about them, is that we think that's a big deal for making things happen as well. So we're just going to go through this. There's the three fuels compared, and we're going to go, and the first section is basically from the creation of the fuel to the delivery. And then we'll get into the technical comparison of the three wood fuels, as well as the boiler systems for the three wood fuels that, pair up with each of these. And then finally, some financial comparisons to give you an idea how these things all come out in the end. The three wood fuels, all readily available in northern New England. They are wood pellets, screened semi-dry wood chips, or what we call PDCs, and green wood chips. We're going to start out with green wood chips, and the first thing you notice is the moisture content, 35 to 50%. Very often it's in that 45% range, and they arrive, and that's kind of the way they fall off the back of the truck. The wide size variation, the chip size and percentage of bark varies, and rocks and debris, different things are possible. There's a logger involved in this, and this is very often why rocks and things can be possibly in the load, because it's done out in the woods at the landing, and they have a chipper there. They have a bunch of good guys that are working on the sorting of everything to make sure that the most valuable logs go where they're supposed to go, and then the secondary logs and so forth. So it's an important thing to say that the green chips are trees that have just been cut. Sometimes maybe they've been sitting around for a while in a pile, but very often they've just been cut. They get loaded onto this truck, blown in by the chipper, and then they take off down the highway. You see these trucks all over my area here in they're traveling any number of different distances to get to. Perhaps it's a pellet plant, and perhaps it's a place like this, which has a big bunker, and the truck pulls in fact, on this sort of ramp in this case, and it all the chips just sort of fall out the back of the truck, which is the nature of the delivery of green chips. They're a live floor truck, and the truck starts up, the floor starts to move. It has this motion that goes on, and it causes all the chips just to sort of walk their way out the back gate, and he'll have to pull forward as that load continues to dump. And it's a pretty big truck that has to be pulled in, and you can see that's a typical building that you might find as a green chip boiler system. They're very often built brand new just because it's so specialized. There is a system of hydraulic pushers that are moving this pile. Again, it's a live floor idea where there's a wedge shape that goes underneath the pile, and then the vertical portion of that wedge pushes the other direction, moving the pile. It's very subtle, but it does basically cause everything to go to this end. The receiving auger on this end, it starts to pull everything then to the right in this case, and gets onto a conveyor and goes up into this big boiler. That's the most typical. And then another angle is a different type of boiler, slightly different configuration, but actually very similar, is that you've got it into an enclosed auger and at the base of this boiler. So just two different boiler configurations. In this case, you've got a lid, perhaps. That's a way they do it in Europe very commonly, is they'll have a lid that just opens up and the truck backs up and pushes it in. Otherwise, the garage idea like this. This is a system that uses, again, sort of a roving auger system, and the truck backs in and dumps it down into this pit. So works out really well. The key is that they're getting a very low cost fuel, and they're putting it into this boiler. It is green. It is, in other words, very wet. And as you know, if you cut down a tree and try to put it in the wood stove or the fireplace, it's not going to do very much. So it needs to have a process within the boiler system itself to actually dry those chips out. And that's more or less what happens. We can talk about that later. The level storage floor with overhead rake is another way that this can be done. And I stuck this picture of chips in here, which is more or less the way it looks when a big truck pulls out of a garage like this. This is a big garage structure. You can see the concrete walls here, and they just back right into this garage. And then they start to drop the load off the back, and it just falls off the tailgate, can't go very far. So they keep pulling forward, every 5 minutes or less, they have to move the truck another few feet to get the clearance. So that ends up leaving this big pile here. And then this is a rake that gets picked up. It's not really as clear as I'd like it to be, but you can see the rake right here. So what happens is that it goes over the pile. So it actually lifts itself up and scans all the way across here, and then comes down and starts to rake like these chips backwards. And then it does it again and again and again. And finally, it uses sonar to figure out what the shape of the pile is currently. And it wants to have it so it's all piled up at the end like this or this. And then that's feeding the auger at the base, which feeds the boiler in the end. So neat idea, above grade, different ways of handling green chips. So next up is wood pellets. 7% moisture, from 45% down to 7% moisture. And that's why they're so versatile. You're using them in a grill. You're using them in a pellet stove. That's probably the biggest application for most pellets in the Northeast, is that there's a lot of people burning these in their houses, and it's by the bag. But the automation side is the most important thing for us. We're talking to a school, and I've once had a teacher say, who is it that's going to bring all these bags down into the basement and feed this boiler? And I said, well, geez, the teachers. Don't you have some kids also that could come down and do that? But that was a joke. So it's bulk fed. This is all bulk fed, and they're manufactured. I'll show you a little bit more about how they're made. And it's a very compact amount of fuel. It's the most compact of all the wood fuels. It's wood chips and are about double the volume of what this is. And you got to look at that for BTU storage. I can get into that later. Here's what happens is you get that same truck that just came in from the woods, and he drops his green wood chips down in the one section here. In some wood pellet manufacturers, they actually chip the logs themselves, and that's all this process is here. You can also get sawdust in from whether it's a lumber yard, it's somebody that's sawing green wood or kiln dried wood. You also could get wood shavings. And in this case, that would be from, say, a manufacturer where they're making furniture and there's a lot of excess wood that they're trying to get rid of. Well, the wood pellet guy would love that kind of wood. It's already pre-dried. So it basically goes in to a hammer mill, gets ground up, and the next step of the process you can see comes down here, and it goes into a silo here, and then a further hammer mill that fine grinds everything, and then it goes into these pellet mills, which are basically compression units that use heat and pressure to form these pellets. And there's no binder in there. They don't melt down plastic bottles to bind the wood. They basically use the lignin that's in the wood itself under this heat and pressure, and it turns into this wonderful pellet that now is fairly durable and can be either put into bags in the final packaging run here, or just a truck can come in and get filled up with pellets. And then you can see this right here is that this is New England wood pellet, and Jaffrey has this same kind of a setup. The truck pulls up, they pull the cord, and the pellets fall into the truck. Because that's neat. That's a neat factor of pellets, is they flow like water. If you took a bag of pellets and just chopped off the corner, it would all flow out onto the floor pretty quickly. And chips don't do that, but pellets do. So that's made this a very interesting product that's really only been in the United States here for maybe 15 years. It's caused a lot of interesting developments in the boiler side of things, especially in Europe. But it's opened up a whole new realm of fueling capabilities. And here's the guy that looks like he's got an oil truck, but he just has a really fat hose into the back of the house, and he's pumping in pellets. So this house could probably use about 10 tons, and it all is just having to do with the situation. This is your typical silo, a steel silo out behind a school. And in this case here, this is actually in the town of Peterborough here, where there's the big semi. That's about 25 or 30 tons in that semi. And it is blowing them into an internal silo inside the town hall. So neat way of doing it. Nobody ever sees the fuel. It just goes through the hose. It's kind of like oil that way. Wood pellet feed methods. Pneumatic is probably the most popular, especially for the smallest of the boilers. It's an easy thing. You just have a loop of air. It's like having a shop vac that sits on top of this thing. It has a loop of air with the incoming and the outgoing. And it comes out here to the silo where it's dribbling those pellets into that stream of air, and they come right back and deposit themselves into this storage unit on the side of the boiler. Another way to do it is to have this continuous flex auger, which is generally it's boiler for boiler. You're going to have one or the other feed mechanism. And in this case, you have a pipe that tends to be, just has very subtle curves to get around to where it has to go, but where they'll really long sweep kind of elbows because it's got a spring inside of it. And the spring is being turned by these motors on the very end of the pipe. And so it's a lightweight situation, but the pellets move easily, and all it has to do is spin this spring, and they just screw themselves towards the boiler. They just go through that area. Next, screen semi-dry wood chips. You can see it's right in the middle, 25% moisture content. So 7% pellets, 40, 35, 40, 45%. It varies depending on time of year and all sorts of things with what you're getting on green chips. Again, it's a varied size, but it is screened, and we'll get into that. The assured quality side of things is pretty important. So there's assured size and moisture content. When a customer calls for pellets, he expects to get something that's 7% moisture or so, and it looks like a pellet. It acts like a pellet. If you put in rocks and big chunks, the customer would say, I'm not dealing with you anymore. It's not the assured size you gave me. There's an assumption. When you get oil, it's an assured fuel. Well, that's pretty much it. So it's able to be delivered by a blower truck, just like wood pellets. That's another neat thing about the dry chips. And it's a lower cost boiler system infrastructure. We'll get into that a little bit. and 35% to 50% less costly than wood pellets. So that's one of the reasons why we got into this whole field, is that we saw this and figured, if it's there, if we make it, someone will come to this market, and it's done pretty well. It really is the middle market, and that means somebody that's burning, 20, 30, 50,000 gallons of oil a year. That's the way we're gonna do it. That's where it's going to succeed, I should say. The source, the exact same fuel. This is chips from the forest that are arriving in live floor trucks. There's that same truck, say, that's backed up there and dropping off his load. And you can see the first step is we screen out the oversized chips. So all we do is this guy loads them into this bin. It's a pretty manual process, the way we've done it for the last few years. And he loads them into this, and this is a inclined conveyor that just brings them up to the screener, drops them off, and the screener is just a shaker. It has these screens on top, and it just what gets through is fine. What doesn't gets bumped over the other side, and then it gets chipped again, and that goes back this direction. There's a giant magnet sitting right here because we found some very interesting pieces of steel in the flow of that wood. So we'd like to pull that out so it doesn't get caught in our blower truck or somebody's boiler. Then in this case, this is our system that we've done for the last 8 years, and it just drops it on the ground, and then we end up picking it up. This is wet wood, so it doesn't really matter, but we pick it up and we move it around. We'd like it to be indoors. We've always wanted it to be indoors, but as a practical matter, there's only so much that you can do right now when you're setting up a new business. So we did it all outdoors, and that's the way it worked out pretty well. So here's the next thing is that we go to, let's see here. I guess I've got that. So here it is. They start out before the screening, they look like this. They're the 35% moisture, but they look like this. A lot of scattered, different pieces. Could be pretty big sized chunks. When a piece of a big trunk of a tree gets pushed through the chipper, there's going to be the early chips, and maybe the later chips from that particular piece of wood is going to be an odd size, or you never know exactly when it's going to happen. But there's a lot of big pieces inside here, and this is just what they look like after screening. So it's a much more regular piece. You go from this to this, and I think that's pretty revealing. Is that's the difference between green chips and PVCs just on step one. So we'd like it to be, I like to say, about the size of a matchbook. It's about as big as we'd like to have it, and there's a lot of scattered sizes. It's much smaller than that. So we dry it down to 25% moisture, and what we do is we manually take from this pile, which comes out of that screener, and you can see the snow hits it at different times, and we dump it into this big bin here, which has a live floor, and it slowly feeds into this dryer. And this dryer, it goes from this end to that end and comes out here dry. Here again, under the weather. A beautiful sunny day, it doesn't matter, but obviously when it rains, we're starting to spend a little bit. We actually stop this kind of production. We'll continue doing this, but then we have to take that much more moisture out of the chips before it finally becomes what we're looking for. But this thing is computerized, and it actually pinpoints the amount of moisture that you'd like to have in those chips. This is a big blower system. We have a boiler back here in this area, this big building, and we're using our dry chips to fuel that boiler. It has pipes that run around here into these giant heat exchangers that blow the hot air through the chips in this step. You can see this is one of the blowers right there, and the chips, this is empty, but the chips would be about 6 inches deep. That's about 6 feet wide, and it takes about 45 minutes to run this 75 feet or so of that boiler of the dryer. So then in the end, we now have improved those earlier slides there. We've improved it so that it's on a covered conveyor that goes all the way into this covered area. Step by step, we improve the process. There's a 3.24 million BTU an hour boiler sitting in this building that's generating the heat for this. There's about a 2,000 gallon buffer tank that works with that's in the background here. And this whole system then is, up and running and runs pretty much 24/7 through the midpoint of the winter. I wanted to show you this just because it's kind of fun. It is a batch dryer that we started out with. You can see that's that same building. And what we did is we made these two, it started out just to be an open space in there with outdoors. We built these doors and we made it so that they could be closed with just a little bit of gap here for a little bit of air release. And what we do is we would pile in a bunch of chips about 5 or 6 feet deep. And we had in the floor are some slats and ducts inside that floor. I don't have a very good picture of that. I couldn't find one. And but we have this furnace that's blowing air through these ducts, these hot air through these ducts that make up the whole floor. So about every 6 inches, there would be a new one of these ducts. And it had wood slats on top with the gaps in them. So it was basically like a forced air system that was circulating the air, and it would take the return air would come in from the top and go back into the boiler, into the furnace. I should say it was a hot air furnace with only 1 million BTU. So this was like a big convection oven, and it would have to run for 2 to 4 days, depending on the weather, depending on the dryness or the wetness of the chips. We're always looking for the 25% moisture. We'd get it most of the time on average, but there's going to be spots that don't get a lot of circulation. It was not a great solution, but it was an early solution. We did for 2 years. We would make about, I think those 2 years, we were around the 1,500 ton mark of total production. So we would come in and pick these up and dump them into the truck, or we'd bring them over to the storage area and keep them for a while, depending on what the demand was. In the middle of February, it was pretty much make them and deliver them, make them and deliver them. So it was an interesting experience there. Okay, so the stockpile, put them in the stockpile here. We have this big covered area. It's where the 25% moisture content chips are. They're impacted by the weather a little bit, but really not that much. That cover really helped, and that was a good way to store them. So we load them into the truck, and then the truck takes off. He's got the big canvas cover over the top, and these are both, I have 2 blower trucks. You can see the 2 of them here. We've got the semi and we've got the fixed body here. And so 14 tons or 28 tons can be delivered through a 6-inch hose. And that's what we're looking at here. So there takes a little bit of time, but 45 minutes to an hour or so, you end up delivering all the chips. And you can see that it's a very simple storage system. It's a big can on a concrete platform. We'll talk more about that, but there we go. It's just a different couple of views here of that. One of the neat things about it is that you can maneuver the truck and not have to have a big driveway, specialized driveway for delivering the chips. You can pull up maybe after hours, depends. It's a little noisy, but the blower, we've done our best to try to tame those blowers to make them as quiet as possible. But they're able to just hook up to a port like this right here. I think these are the ports, and then there's a vent. You always have to vent on an exterior, but you're able to get that truck up, within 70 feet or so, and just pull the hose over there. Now, the guys like to be as close as possible, but that's it. So here's the foundation. You put in a really heavy slab, frost slab, and then you build it up for the ring of the base of the silo. And this typical one is about 19-foot diameter and 20 feet tall, holding about 45 tons of chips. So, 1 to 3 truckloads, depending on, the truck that comes and makes that delivery. What's inside of it looks like this. It's a big, what we call a sweeper arm or a rotary extraction device that spins around, and generally the back-to-back idea is pretty important here. You'll find that it's an ideal to have things fairly close, but I actually could put a whole room in between these 2 things with just a rigid auger passing through that room. It could change angle, because you can change angles with augers, but multiple augers. So there's some flexibility, but if you've got your choice, do it like this. It makes the most sense to make them just back to back. So here's the real picture of what goes on in there. And here's as we're assembling these, you can get a best view of this. Otherwise, it's going to be covered with chips most of the time. There's an open gutter, I call it, with an open auger inside of it. And what's happened is that all the chips are piled on top of this. And so this is a very tensile steel that is spinning around, and it actually winds up around this when the pile's heavy. It could be a 20-foot tall pile. And so it's keeping this arm from moving very far, but you'll get it pushes them into this gutter. And what you'll find, anytime that you have dry chips like this or any wood chips, is that you can pull them out of the bottom, but pretty soon it arches and you've got this pile that doesn't want to move anymore. So you get the first few chips out of there, but after, very shortly, you'll have nothing happening. So you've got to jostle these things, and that's what happens. You push them around in circles and they go up the auger. The auger is feeding only when the boiler is calling for chips, and they're very much under control, reacting to the load. So if there's no real load, they modulate down, and so everything is under control. Just like with a pellet system or a green chip system, actually, it's not that different. Fuel quality is assured. That's a big deal. The bull wood is what we request. That means it's the main trunk of the tree. It's also, screened, and the Trent metal rock sticks and things like that are eliminated. Things that would jam up those rather lightweight augers. That's really an important thing to think about, is that the augers are made for these. And pellet augers would not be able to handle these chips, and certainly green chips of various sizes would not work well. Required minimal management, so you don't have any problem with we're comparing ourselves very often with a green chip system, because that seems like a really low cost fuel. So why not get that one instead? Well, you've got to manage your fuel when you've got green chips. So you end up with possible freeze ups and clumping, or you've got to have your silo indoors. A heated silo space is the most important thing. You'd end up with composting, which means it just starts to build up some heat. With the 25% moisture, we really don't experience that. I can have these things sit all summer long, and there's no composting happening to any extent. There's a little warmth, but it's nothing like you might experience in a compost pile. And the mold growth as well is very much minimized as a result of that. One thing we find, that 25% moisture content, when it is a true 25% and they're all stacked up in the silo and it's -10, -20, you're going to get a little bit of freeze up from moisture condensation on the sidewall of the silo, but it just stops right at the outer foot or so. And you're not getting that kind of clumping. I once had somebody that had a silo full of like 35% moisture chips that was delivered by somebody else, and it froze up solid. He had about a 3-foot hole in the middle of a 19-foot silo. That was not very practical. So they was relying on the gas backup for a long time for that one. But that's part of the quality control side of things. So now we'll just look at some technical comparisons to give you some better ideas. Here's that original slide that shows the 7%, 25, and 35 to 50% moisture content is one of the biggest variables. What do they have in common? Well, everyone is sourced from a regional forest. They don't like to go too far. Sometimes pellets can come from, Ontario or something like that. And you'll find them in your hardware store. Well, that's fine. But, when it comes to bulk, you can only truck something so far and before you just start losing money, or it's not a viable product. So you can only go so far, whether it's pellet chips or even green chips. There's got to be someone willing to pay the money on the other end. So within 30 miles, within 50 miles is most typical. And the second thing is it's bullwood. It means it's the central blue core of the tree there in the picture. That just means it's not a lot of small branches. There's certainly no needles or leaves. You're having the best ratio of bark and wood. So it's the bigger piece of a tree. These are low grade trees. We're not burning trees that could be used for anything but cordwood and perhaps paper grade or something like that. So let's just compare this. I love this slide because it shows what you're buying when you actually, sort of like the buyer notification here is that when you're buying green chips and they're 45% moisture, you're getting 900 pounds of water and 1,100 pounds of wood. It's just kind of the way it goes. And when you're buying pellets, you're buying only 17 gallons of water and 1,860 pounds of wood. So you're getting a lot more wood. It's dry. It's ready to burn. That's why pellets cost what they cost. Because you know what? They started out with this 45% green chip, had to boil off all this water to get it down to 17 gallons. And here they had to buy that much more. They had to buy a bunch, like basically almost tons of wood in order to get what they have here to sell. So $250 a ton doesn't sound so bad because you didn't have to pay for all that water. So we're at 60 gallons, kind of in between the two here. And obviously that's one of the ways we define what these different fuels are. The heat content in gallons of oil, this is a net. So if you say I burn 120 gallons in a month, you would also burn 1 ton of pellets. If you had a pellet boiler in that case. PDCs, it's 10 million BTUs versus 13 versus 7. You're looking at 93 gallons per ton. So BTUs or gallons of oil. I think gallons of oil give us, it's sort of a relative scale that most people are familiar with just as a long life experience here. So I think that's a good way to make these comparisons. Looking at other fuels, if you're involved with natural gas or propane, something to compare. Not to dwell on these, but this is a PDF you could request if you wanted to understand more about these different fuels or get these slides. The bulk density, 40 pounds per cubic foot. One bag is 40 pounds, most typically, as you find them in the hardware store. So 50 bags equals a ton. And here you're looking at, you can see it's about half the weight per cubic foot. And obviously the wetter it is, it's the same volume, but the wetter it is, the heavier that is going to be. So volume per ton and so on here. When you're calculating out how much space am I going to have to devote for storage. So if you want to do it inside your building, you can do that with both pellets and PDCs, say in a basement room or something like that. We've done that in a couple of different installations. But mostly pellets are what goes indoors. And you can see that it's half the volume. I can put a lot more heat down there as a result of doing that. So here's another thing, just tonnage and volume. How many yards is it going to take to do this? To offset 30,000 gallons of oil, which is a common thing that we'll be talking about with people. We're trying to offset that. So we're going to burn 249 tons of pellets. That's 10 fillings with a 25-ton truck. And this is the volume you'll be burning. And then same thing with the PDCs, 321 tons. That's 29% more tons than pellets. And the green chips, we're going to have 51% more tons than PDCs, or 95% more than pellets. So you have to get ready for that volume. That's why they have the pits. That's why they have this big storage area. And that's the investment. That's the difference. And here we do this above ground with a cheap storage area. Here it's pretty hard to avoid having to put in a big concrete bunker. So the initial investment is one of the big things that we avoid with the PDCs. Cost per million BTU. And this is, again, this is net. This is after they're burned in a typical boiler. We're looking at, the 80 to 84% efficiency. But the best efficiency, the most typical efficiency with each one of these fuels, pellets would be the 84%. That actually drops as you go here, but it's the best you can get by any particular type of boiler. And you'll say, you're looking at 7 million BTUs per ton. It's $75 a ton on green chips. Say if on a good quality, nice green chip, $10 is what your cost per million BTU is. PDCs $11.54. So a little more money, and $17.95 with pellets. There's the thermal RECs in New Hampshire, AECs in Massachusetts, but their price has not been as good as the price on thermal RECs. So let's just talk about New Hampshire right now. Is that when you apply thermal RECs, which basically is a way to make money on using a renewable fuel that has to do with the renewable I think it's called the excuse me, I've just forgotten the name of it, but there's a law that is passed that power companies need to produce X amount of their power by renewable methods, by renewable fuels. And solar is obviously one that was the first thing. They make electricity directly. So that's a way that they were able to satisfy this requirement. It's an annual requirement. They have to have this certain percentage covered. Because they don't do this themselves, they have to then pay somebody to say that they did this. And that's stimulating people to go out there and actually do it. And maybe the power companies would someday do it themselves. But at this point, they're basically buying RECs. And so you sell this REC to the power company, they give you this money, and this is what it ends up reducing your costs to. So you go from $17.95 per million BTU down to $12, or from $11.54 down to $5.69. The idea of I might just tell you, it's the Renewable Portfolio Standard. Thank you, Mike. The RPS. So just to use thermal RECs really makes such a huge difference. And I've got another slide I'll show you that sort of compares this to other fuels and gives you an idea of what a difference it makes. But this is one of the reasons here. You can see we're half the price of what pellets are once they're applied. This RECs are applied. So very good. Oh, here's a slide that shows that compared to regular fuels. So let's just look at this. You've got pellets coming in, and this would be Massachusetts or Vermont. Pellets, $2.40 a ton, is a pretty good price right now, actually. So call it $18 per million BTU, and that compares with oil at $2 a gallon. So that's really where we're looking here. It's $2 a gallon. When I do PDCs at 125 a ton delivered, you're looking at $12, and you can tell that's close to oil at probably $1.25 or something like that. Propane, very different pricing. It's not the same amount of heat per gallon, and it adds up. But if you were buying propane at $1 a gallon, it's going to be close to what PDCs are, and so on down here with the green chips. People say they can get green chips for $30 a ton or something. Well, good luck with that. That's probably the guys asphalt on the side of the road just putting everything in there, which is called a whole tree chip. Not a really good thing to be putting into a boiler that's not really made for that. So you've got to go to a guy that you're getting a good quality chip, and that's where you go, the $60 to $75. With the thermal RECs now, we've just applied, you can see that it jumped, the PDCs dropped from 1203 in red down to 569. So now what are the cheapest fuels around? It's these three guys, and then we get to oil at $1 a gallon, as if that's going to happen. And then it could, I guess, you never know. Natural gas, we don't compete well with natural gas. It's just never really been an interest. People are stuck with oil. They don't have natural gas. They're talking to us. And then pellets, you can see on the way up in the scale there. So interesting, gives you some perspective. How do they differ? Best applications: pellets, homes, small commercial buildings; dry chips, schools, manufacturing, nursing homes, district heat of smallish, whatever. Green chips, large multiple building campuses and industrial situations would be most typical for that. So if your building is burning 1,000 to 30,000 gallons of oil, pellets are something you got to look at. It might be the least cost, especially the upfront costs. PDCs, 20,000 to 100,000 gallons. There's pluses and minuses here. You can go either way. I've got somebody burning 180,000 gallons of oil who sticks with the PDCs. So I should say the equivalent of. And then green chips, 90,000 gallons of oil to huge. You want to heat Dartmouth or whatever. Nobody does want to do that anymore, but there's a lot of college campuses, St. Michael's and so forth, that are heating with wood, and that's all green chips. They're offsetting some of these 1 million gallons a year, so that's your least cost. And again, the compact size, easily adapted, is the big difference with pellets. Larger boilers and storage with larger footprints, and big boilers with big storage and big footprints overall. Those are the biggest differences, and they just have to sort of, digest that and look at each situation and see what's possible. wood pellet boilers. I'm going to go through the boiler technology here just to show you that end of things, as well as how the fuel gets fed into them and all that. So the pellet boilers are very straightforward. These are those pneumatic fill lines coming in to the side of the boiler. Each one of these has its own silo. Each one of them is filled independently. They go and they turn on and off in stages. Each boiler has a modulation that can go from, say, 30% of max up to 100%, and it's watching, the control system watches the load to adjust whether it's one boiler or all three boilers at full blast. The boilers in this case go up to 191,000 BTUs, close to 200,000 BTUs an hour. They have control panels, and there's a lot of things to talk about there, but it's a nice, efficient, well-designed system. These are Austrian boilers that are by Main Energy Systems. Main Energy imports them, modifies them a bit, and has them all ready for the U.S. market. And so here's an interesting silo that they use, that the pneumatic silo goes up and over. This is a very space-efficient silo. You can see it's kind of a cube, and it works very nicely. Again, if you've got two different boilers, you'll have them feeding from separate silos, most typically in the bag kind of thing. You could have a single big silo outdoors with multiple boilers. And there's multiple pipes that are coming in from the inside, the outside, going into the boilers. Each one has its own pair of pipes, and that's the pneumatic delivery again from the silo into the boiler. So these two pipes come in and fill this little side piece, which is what we call a day bin. And this is the Froling boiler. So it's another Austrian boiler that we've had very great success with. Just how do these things burn? In the Froling boiler, it has this little day bin. It has enough for 12 hours of burning. It fills up about every 12 hours on a timer. Little auger turns on, and when it does, it pulls these pellets and drops them down this chute into the flame. The neat thing about pellet boilers, the neat thing about pellet stoves, is that it keeps the fire burning at a really nice hot level. It doesn't vary except when you're really turning on and off initially, but obviously it has that really nice tight flame that really gives you a control over it. You're burning everything. You're not just creating a lot of creosote. And it's going through the water here. The flame, the hot gases go through these pipes, and the pipes are in the midst of a lot of water. And you can see that right here again. Inside each one of these pipes, because the ash builds up over time, these are on cams, and they actually scrape the tubes to try to prevent the ash from building up. And over time, that does build up, and you need to end up having it cleaned. But in this case, it has its own little ash compartment there. I'll show you more. This uses a couple of oxygen sensors in the outer stack so that it watches the level of oxygen, which tells it how well it's burning, and it adjusts things accordingly. So it's basically like your car with the oxygen sensors. They call that a lambdatronic system. This is the Main Energy system again, and they push their pellets up from the bottom onto this burner plate. You can see the burner. This would be all in flames. That's the air, the starter. These start and stop like a regular oil boiler. It gets this thing burning, and that's the burner, and then it goes through the water and so forth. I won't get too detailed on that. I did this the other day for a group that wanted to see about maintenance, and I thought, let's just keep that in for now, and I'll go through this quickly. But the ash container is really the one job the owner has to do. They want to make sure that once a week, especially midwinter, you go down and you check it and you empty the ash, make sure that it's ready to go. So these are the two different boiler brands. They have these two different types of boxes. This is very convenient the way they've set that up, but it's not that different from this one. It's just got a really neat way of unloading it. It is pretty different, actually. I really like those. The control panels, look at it. It's telling you if there's an error message. There's a lot of controls that are safety-oriented controls. And there's a lot of things being looked at, a lot of sensors. And if something's not right, it's going to shut itself off. And you can rely on that. It's not always convenient, but it's something that you certainly have to thank them for having such a good design that it's nice and safe. There's also a dust cyclone for pellets, because after a while, sometimes the dust starts to build up. So as it comes from the silo, it actually passes the airstream through this. Now, this is after the pellets have been deposited in the boiler, but that dust would continue to flow around and around because it really doesn't have the weight to drop out. So it goes through this cyclone, and that then fills up with sawdust, and that's something you'd want to check too. Listen for odd noises, irregular operations, something's going on, give us a call. Monthly, generally monthly with somebody who's burning a lot of this. If this is a school, you're burning a lot of pellets, probably every month in January and February, you're going to be getting a cleaning just to keep everything nice and efficient. The firebox, the heat transfer tubes, all the nooks and crannies on the top here where the ash goes around the corner and back down again. You just need to clean it out. People can be taught to do that, but our guys are good at that, and that's a good thing. So it could be either way. And an annual spring cleaning is always a good idea. Clean everything out. Look at the chimney, look at all the breaching, make sure everything is completely cleaned out. And, check things. That goes without saying in a lot of ways, but a good mechanic to take a look at it. Dry wood chip boilers to follow in just levels of complexity. There's actually boilers that can burn pellets and dry chips. They were developed that way. The dry chip perhaps was the priority. The pellet's a second fuel that can be burned in these. A green chip boiler actually can't burn dry fuels, a lot of them, I should say, because they're not designed for the high temperatures that could result of burning the pellets. That relies on the moisture to actually cool things and keep things right. So that's another interesting difference between the fuels. But there's, like I say, a lot of these, almost every dry chip boiler can burn pellets as well. So in this case, though, the way they flow is this rotary extractor. So it goes into the back. Again, they're being loaded. In this case, there's 4 of these rooms side by side that look just like this, 4 boilers side by side. And there's 4 hoses that deposit the chips into these rooms. So it's kind of a neat installation I can tell you more about. But there you are again, the auger goes in, it goes through this airlock, which the technology, again, I say there's a lot of safety factors. This is one of the main ones. We don't want the firebox in any way to possibly have flames go out into whether this is full of pellets or chips. It just doesn't matter. So there's an airlock, kind of called a Belimo valve that's here that prevents that. And we could talk more about that, but it's pretty easy. Touch screen, visual, you can see the temperature, see what's going on. This again is the auger feed. Looks very much like a pellet boiler, but just that difference. Things are a little heavier. Things are a little different. The grate has to be cleaned in a different way. It's automatic self-cleaning in all cases here. The ash container and all that. So here's another one, which is a bigger boiler. This gets into the million BTUs and on up. And you're augering the pellets in this way. This big burner gets fed from the bottom. The flame starts here, and the hot gases go up here and burn in a secondary situation. And they actually come up this way, and then they go up and then through the tubes. And then you can see they make all these passes. That starts to extract all the heat out of that gas. And finally out the chimney. And before it hits the chimney, it goes through these cyclones, which actually spin the exiting gas to get the ash out of that and the particulate out of that. Because the bigger the boiler, the more regulations there are to meet. And there's just more, you have to deal with this. So you end up with something that's going to actually meet the regulations. But generally with PDCs, because of their dryness, just the nature of the more refined fuel, is that you don't need an ESP. And the testing has shown this. We've had some great results in the testing at these boilers. And the ESP is sort of like the last resort. It's putting, not a Band-Aid, but it's a device you have to put on, like having a car that has pollution coming out of it, and you've just got to deal with it. So you put one of these on and that fixes it. But if you can get a boiler that burns clean enough, which most of these with the dry chips do, with the right boilers, whether it's the Schmidt boiler or a Wiesmann or some others, you're able to master it. And that's one of the good things about PDCs. They burn a bit cleaner. So the typical task, again, you're going to empty the ash. That's the story. You just have to empty that ash. And so I'd say some places have a lot of boilers and a lot of ash, and they say, well, let's get a multiple cans and we'll be able to swap them out really easily. And that's a really good idea. But it's this in the bigger boilers. This is a Wiesmann here. It has the rolling cart, and it's in the front of the boiler. You can see it's on the two sides here, front and back here. But that's where it is. They'll also, on the bottom of the cyclone, which in this case is separate, it'll also have another ash container, and be the same with the Schmidt boiler. So, you open it up, you open up the front door on the smaller boiler, and pull this ash container out and empty it out and nest it back on again. So your general task is to observe things and see what's going on a day-to-day basis. And then every 600 hours again, you really should be considering a cleaning. It's mandatory with the Wiesmanns. I think it's very much suggested with other boilers. Schmidt claims they don't have to have this cleaned quite so often, and we're actually finding that. But we're pretty cautious, and we send our guys out to on a contract basis to clean these. It means these are horizontal tubes now, so they tend to be clogged up more readily. And they have a blast system in there, blast air that goes through and blows the ash out the best it can. But after 600 hours, it's time, and let's brush them out independently and clean everything out. The breaching and so forth needs to be looked at. And then the annual maintenance, pretty much the same idea. Clean out the breaching again, and have the chimney cleaned by a professional. Check everything, make sure everything's running right. So not to get too deep into that. Greenwood chip boilers, again, here's that system. The boiler itself looks very similar. The biggest difference between this boiler and the dry chip boiler, or even a big pellet boiler, would be the type of grate that it has. In this case, it's a moving step grate that moves things down the line, and has the air injection and so forth. That the other big factor is what is the nature of the fuel, how much air needs to go in, what's the mix, and they're all engineered to be able to do this. So with the Schmidt, that's how that's done. And you can see the pass is very much similar with the multiple passes to extract all the heat out of it as possible. This is a Wiesmann boiler with the same idea. So a bit of a neater picture. So you've got the same kind of a grate. The ash is flowing off here, falling off the fire, and being pushed down into an auger that pushes it into a container. That's how that container works. Every one of these has an auger that grabs the ash and brings it out. And obviously there's a point where if you don't empty the container on every one, whether it's a pellet boiler or this, that if you don't empty it, it's going to be jammed. It's going to start to backfeed, and guess that impacts your fire. And actually the unit will generally turn itself off because of the jammed area, airflow, and so forth. So it's got all the sensors do this. So here's the hot gases come up here, and in this case they actually they turbulate and spin around in here, and that's a very hot flame. It's almost like having a gas flame right there. And then it goes through all the tubes and then finally out the chimney. This is that air injection system that actually you'll hear this every so often, and that's a blast of compressed air that gets blasted down these pipes at random, not all together, like 2 or 3 at a time, and it blasts through there. So that's kind of cool. Important features that they ignite themselves. They turn off when they need to. If there's no need for the heat, it turns off, turns right back on, modulates up and down. The economizer is recirculating flue gas, trying to cool there's various priorities it has. It wants to keep the temperature just right in the burn chamber. So it'll recirculate gases. It does this intermediate cleaning with the air blasts. The flue gas recirculation and all as well. Automatic undergrate de-ashing, so that takes care of that chore that you might have to do on a bigger boiler, a big green chip boiler. Pneumatic boiler tube cleaning, and the de-ashing, just to show you some pieces. Green chip systems have the need for these ESPs. So just to tell you what an ESP is, an electrostatic precipitator, there are these electrically charged plates that the smoke passes by. There's a lot of plates, and the particles automatically just get attracted to those plates because of that charge. And then they clean themselves by banging or whatever. There's different methods, and all the ash falls down into containers. And what they find is if you put it through an ESP, you've got very clean gases coming out of your boiler. Again, the weekly tasks very similar, just bigger scale, a lot more ash to deal with. It's not massive amounts of ash in any case. You're about 1% of, 1 to 2, maybe 3%, depending on the fuel you're burning. But 1% is pretty typical, and that's not a lot of quantity in the end compared to the fuel you're using. Your tasks that you have to do on a regular basis, you actually have to clean out that ash. And that would be on a daily basis. You actually have a little box on the side that you need to clean out as well as the containers themselves. So that's the boiler's ash collection area. Just rake that out to be sure it's in good shape. Just a little bit more to look at, but still you're not looking at more than a half hour a week to be able to look at this thing. Otherwise, you're just looking at the control panel and saying, is it working well, and listening to it and see if it's okay. There's nothing to do on these style boilers. And other style boilers, there is some daily work. And so that's a matter of deciding what boiler you'd like to get. And I don't happen to handle those. So this is the way these all work. And we like the automation of this type boiler as well as the high efficiency that they have. So same idea, spring cleaning, important, every 600-hour cleaning. And, that same guy in there cleaning out your tubes. Just one dry chip boiler installation, just to show you. One is Maplewood Nursing Home, and that's in Westmoreland. And we put this giant 4 million BTU boiler. It had to be tested on site by the New Hampshire Department of Environmental Services, and some engineers and so forth all on site there looking at everything. And it passed without an ESP. How about that? 4 million BTUs with dry chips. And here's the silo behind the building. It actually directly feeds into the boiler that's just on the other side of the wall there. And this is how it gets loaded up with the semi here, backs up and fills the silo. They're going to offset over 100,000 gallons of oil a year at this site. Next week, we're going to do a number of sites. We're going to just show the projects and give you an idea of how they work. And they start to look alike after a while, but there's some interesting variations between them. Financial analysis, just a little bit about how do they differ. It's the system cost and the new cost of heating fuel. It's pretty straightforward. You can't buy, you could buy a car and say they're all the same. I'm not going to worry about the price of gas. But when you're looking at this kind of an investment, the initial system cost plus what's it going to cost me on an annual basis, projected out so many years, is there a savings? We like to think that it doesn't have to be a radical savings, but if you can match the price of your favorite fossil fuel, what difference does it make if you buy the biomass boiler? It might be the preferred method as far as we're concerned. It is. And, why does it have to fight and be incredibly, much cheaper? It is much cheaper. And that's the good thing about the dry chips and the green chips especially. But but if you're just looking to heat your house, you're going to go with pellets. It's the least cost for a fully automatic system and for small users. And same thing with the dry chips up into that middle range, and the green chips for the big ones. We've seen that before. Now here's somebody that's burning LP propane, 40,500 gallons of LP a year. And they're looking at their options. What is it going to cost for me to make this investment to offset that amount of fuel? And in this case, it's looking, the initial price was for a PDC system or a wood pellet system. It was basically the same thing with the silo and the boiler system, but there's a $20,000 savings to go with wood pellets. So that was the difference there. And then if I wanted to jump up to green wood chips, it was $750,000. Now in New Hampshire, there's a rebate. You can get the rebate on either one of these systems because this is pellet capable. And so you end up without a rebate on the green chips. Your net cost is here and your coverage is here. Green chips very often have a slightly less coverage because they don't like to work in the shoulder season so well. So that's typical, but it doesn't have to be 90, but that's pretty typical. The new biomass fuel use now. So here you're looking at PDCs at 285 tons and you're looking at pellets at 221 and green chips at 364. You're also looking at natural or LP gas use of 2,000 gallons, 2,000, or because it's 90%, it's 4,000 gallons. So there's a price of $2 a gallon on the LP. That's a variable that you can put in. The price of the fuels, 125, 245 for pellets, 75 for green chips. Again, you could vary those prices and see how that comes out. But it tells you what your annual fuel use is going to be with the cost, with both LP and the chips, whatever kind of chip you want. This is sticking with LP 100%, as you can see here. Just going to stay with the gas, and there's no cost on the system. It's just zero. Someday you'll have to replace that, and probably within a 10 or 20 year time span. So you could put some money in that, but you're comparing your annual cost. You can see you're looking really good here, but you do obviously have some thermal RECs you can apply to this. So you know what? I think there's a problem on that one, and I didn't fix that, and I apologize for that. There'd be fewer thermal RECs on the green chips, but if they were all at 95%, they'd all have pretty much the same 865 thermal RECs, and that's a problem. We're actually giving them some credit that they shouldn't have here on the green chip side, so I need to fix that. Things like that happen when you're doing all this math here, but here's the net capital cost plus 10 years of fuel use. There's a little technicality here is that T-RECs are price supported for 7 years more. And I like to put that in, and we don't know what they're going to be in the future. So I say they're down to $6. But in the end, your total annual fuel cost is this and this with thermal RECs. So this actually is going to be a bit more than that, but it's probably going to be about the same as the dry chips or something on that order. Anyway, 750, 916, and don't trust that number versus $810,000 for all, just sticking with the LP. That again includes the capital cost plus 10 years of fuel. So, you know, you're better off with the dry chips, the pellets, a bit more. And as you go down the line here, 20 years, you're looking at 1.6 million. And all of these are less than what the gas was at that flat price of $2 a gallon. Is that the best price for a gas? Maybe if you're a big user, you'd be down to $1 a gallon, and that would skew things pretty radically. But that's the kind of analysis we can do for you. In the end, this is kind of neat. Here's you're staying with the LP gas. You obviously started out at one price of $0. And then just add the annual cost at $2 a gallon with, again, even the consumption is identical every year, and that doesn't happen that often. Then the PDC boiler is the brown line. You can see it crosses right about year 8, and then you're home free. And then you can see that the alternate LP, the pellet boiler system in the LP starts out right here and moves across and crosses eventually at year 11 or 12. That's just, you know, there's ways of looking at this. The green chip, again, I'm not going to say that that's absolutely accurate, but you can see how it hovers until the very end. And that's pretty typical there, that it just sort of hovers at the price. It narrows down. In 20 years, it starts to look the same as PDCs, but it takes a while. So if we've got some questions, I'll open up the chat screen so I can see it. And if there's anything else that you'd like me to talk about, I'd be happy to do that. But I think I've covered a lot of ground here, so you're ready to go. But just go to that chat. I think you pull it from the top or the bottom. You just run your cursor up there, and you'll see the chat balloon, and just click on that, and you will see what's going on. I'll see if anybody had a question here as we did this. No, it's more about the muting and so forth. Okay. Yeah, and you can, if you wanted to talk, you could, but most people don't like to do that. So if you've got any others, can we get copies of the presentation? Yes, you can. Just write to me here. What do I have here? There we go. Jim@FrolingEnergy.com, and I will be glad to send you a PDF of the presentation. Go to our website. You'll see under the resources tab, you'll see that this will be recorded eventually. And there's three other presentations that are there right now, so you can check those out. We've got these biomass webinars coming up for the rest of the month here. On the 14th next week, we're going to talk about the 6 dry wood chip projects. On the 21st, we're going to do air emission compliance with John Hinckley. Excuse me. If you're contemplating a big boiler, then that would be a good one to go to, because he's going to talk about the compliance path that you have to follow. And then on the 28th, district heating and other biomass projects in Europe, which is presented by Schmid Boiler Company. They're going to show some interesting installations, and district heating, I think, is done a little differently over there, and there's a lot to talk about on that. And then there's a number of other very interesting projects that they do. All right. So I thank you for attending today. I don't see any questions. If anybody's got one, put it in soon, and we'll answer your questions also by email if you've got anything. So dry wood chips, people say, you're the only guys in town that do this. Well, it's true, but somebody had to do it. We were the first ones in the U.S. to actually start to make them. And we were putting a lot of bigger and bigger pellet boiler systems in, and, putting like 4 pellet boilers in a row to try to get the output. And we said, we need not only bigger boilers, but we need to have maybe a cheaper fuel, as the price was riding up and down, and oil, I should say. And so to be able to beat the price of pellets by that 35, we guessed it would be in the 35% range, and it turns out it is. And then with the thermal Rex, they came along and brought the price down even further. So we invested. We had a customer that said, hey, if you build it, we'll buy them. And so we built their boiler room for them. And after 1 year of burning pellets, they came out and we made our first delivery of dry wood chips. And they've been buying a lot of wood chips since then. So we just expanded bit by bit. And so you build another boiler in, and you're able to sell a few more dry chips. So if nobody was out there with boilers, we wouldn't have the chips. And if we didn't have the chips, they wouldn't be buying boilers. So it's a step-by-step. Pellets went through the same thing. And finally, you get enough customers to make the whole thing work. And that's been our story. Hope I've answered your questions. Take a look next week if you want to see some installations of how these things work. And I encourage you to look at the other 2 as well. So I'll end this right now. I appreciate you being here. If there's any other questions, you let me know by sending them to jim@frolingenergy.com. So thank you very much for attending today.